Today, we are briefly going to discuss the idea of hot springs being the incubators of life. Firstly, what are hot springs? Hot springs are natural occurrences of geothermically heated water released from the surface. The water is heated by the Earth's mantle either through contact with magma in volcanic areas or hot rocks in non-volcanic areas. Temperatures vary depending on location and heat source. Despite the extreme conditions, it's still possible to find life in hot springs. Thermophiles thrive in severe temperatures, with scientists recently discovering organisms such as Methanopyrus candeleri being able to survive in conditions up to 120 degrees Celsius.
Specifically, hydrothermal vents are a type of hot spring associated with volcanic activity, typically found near oceanic ridge crests. They can form black smokers, which can grow up to 50 metres tall and give off large dark plumes of smoke, which contain sulphur-based material. Black smokers are formed when sulphur precipitates come into contact with cold deep-sea water. Lack of nutrients, sunlight and food can lead to the assumption that life would not be able to survive in such an environment. However, scientists have discovered that this isn't the case.
So, why exactly are hot springs a point of interest? Archean oceans were an organic soup of nutrients. In the Archean era, the entire volume of seawater would take less than 1 million years to pass through mid-ocean ridge hydrothermal systems, whereas today it would take 10 times longer. However, as the production rate of nutrients is presumed to be low, with NH2 and CH4 having short atmospheric lifetimes, it seems unlikely that life began in the open ocean. Rather, it is much more probable that life started in hydrothermal systems.
3 key points indicate life may have originated in hydrothermal systems. First, on Archean Earth, the hydrothermal systems would have had the right partial pressures of NH2 and CH4. Secondly, large amounts of phosphorus were present in the hydrothermal systems. Finally, inorganic catalysts were highly available. When large volumes of water passed through these altered rocks, the pH, chemical content, and temperature were readily adjusted. Zeolite minerals would act as a molecular sieve, allowing small molecules to pass through, retaining the large molecules.
Now, moving on to RNA. The RNA world can boast the first stage of evolution. Life was self-replicated RNA molecules and used recombination and mutation to explore new functions and adapt to new niches. RNA is able to splice out a length of itself and act as an enzyme. As a result, enzymatic activities would develop by using RNA cofactors. RNA would bind and synthesize proteins, eventually taking over the role of an enzyme.
So, to bring everything together, the relationship between hydrothermal vents and RNA is crucial to answering whether or not hot springs can be incubators of life. Hydrothermal vents were likely to be present in the oceans of primitive Earth. While the high temperatures within the vents wouldn't allow synthesis of organic molecules, it would result in decomposition of organic material. The vents appear to be the most likely site for inorganic construction of RNA to occur.
So, in conclusion, from the evidence we have presented, hot springs can be the incubators of life.